My name is Arian Velayati, and I'm a PhD candidate of petroleum engineering at the University of Alberta. And thank you for watching this short presentation on our research. Today, I'm going to talk a little bit about the emulsions and the role of emulsions in the petroleum industry, and how we are conducting experiments and doing research in the lab on that specific topic. Like any other engineering work, the final goals of this research is to improve the efficiency and lowering the energy that is used in the industrial operation. In this case, production from hydrocarbon resources. In a highly efficient system, the costs are reduced and the environmental impacts like CO2 emission is reduced as well. But such study is not possible without having a reliable model that represents the actual physical phenomenon that is happening. In our case, we are looking into emulsions. But what is an emulsion? Milk, cream, ointments, these are all emulsion products. Emulsions are widely used in many industries, including the pharmaceutical industry, the food industry, and of course, the petroleum industry. But let's get into more details about the nature of emulsions. Emulsion is a system of liquids that are not quite soluble in each other. One phase is then dispersed in form of droplets in another phase, which is the continuous phase, and it contains the droplets. In case of milk, the droplets are the fat liquids, or liquid fats actually, and the continuous phase is the water. So you have an oil in water emulsion. But the thing is, the phases and the liquids in this emulsion tend to separate very fast. And that is why we use emulsifiers and surfactants in the system. These surfactants cover the droplets and change the molecular forces in a way that the phase separation in the emulsion is delayed. As I've mentioned before, emulsions are also produced in the production of oil. It could happen anywhere. Formation of emulsion can happen inside the reservoir, which is the formation from which you produce hydrocarbons, or inside the well or the downstream. But the most dominant type of the emulsion that you get in this industry is a water in oil emulsion. Is it wanted or unwanted? It is absolutely unwanted from a production engineering perspective, because the way this type of emulsion flows is very different from its constituent phases. It is more thick, it flows harder, especially in case of a water in oil emulsion. That is why we are interested into looking into behavior of this emulsion in different conditions. So we are trying to build a model in the lab, a model emulsion. A model is a representation of an actual physical phenomenon with features similar to that of the actual physical phenomenon. In this case, we are trying to have emulsions that are similar to the main properties of the emulsion that is formed inside the reservoir. It is not easy to have access to the bitumen from the reservoir. And even if you have access, there's always the risk of fire and explosion and the safety risks. So we are using green emulsifiers and we are using other components to have a reliable model. And this model emulsion should mimic some specific properties of the actual emulsion that is formed inside the reservoir, including the droplet size and droplet size distribution, and more complicated ones such as the viscosity or how it flows and the stability of the emulsions. Thank you very much for watching this short presentation, and if you are interested to know more about this research, please check out the FES website.
Thank you so much for watching Future Energy Systems video. Make sure to subscribe so you don't miss any of our exciting content. Check out the links below to our website and learning page where you can find activities, learning extension, and more. You can also sign up on the website for notifications for future videos and interactive opportunities. There's so much to learn as we explore our energy future.